Okay, welcome everyone to the Ontology Summit 2026. Today is the 22nd of April 2026, and this is our first synthesis session. So what I did was just to give everyone a reminder of what was covered in the various sessions. I grabbed a slide from each of the speakers. So this is what I've given here is pure outline, not synthesis. Gary, perhaps when you a little later, if you could give a little bit more about your synthesis, that would be great. So Gary has already started an excellent synthesis. So here was this was Gary's introduction from his first slide. So as I say, Gary has done an admirable job of doing synthesis of the first track, and hopefully we can hear more from him.
Yeah.
Do you have anything you want to say right now before you leave?
As you mentioned, I have to go to another meeting for a while. What I was trying to communicate here is that AI consists of several components, of which knowledge, represented by ontologies in a formal sense, is one part, and that the learning part has been emphasized very recently, but that I think we need a balance to truly get to AI. I pointed out certain, people think of current AI as machine learning, basically. And I've tried to present some ideas in terms of the value of semantic resources and particularly ontologies to improve machine learning. And let's not forget reasoning. Reasoning depends on the type of representation you have. So that's one of the major thrusts of what I was trying to get across here.
Yeah, sounds great. Then Ram gave his presentation on ancient Indian philosophy. And this is his last slide. This gives a rough summary of what he had presented. Are you here, Ram? I guess he couldn't make it. Then we had Randy, who gave an interesting classification of AI systems and compared them to slow thinking and fast thinking. This is one of his slides where he placed some of the current AI systems along this continuum. And Pascal gave his presentation. This is just one of his slides and gives a rough kind of conclusion to what he presented. So just a reminder of what he did. And Manas gave a presentation on interesting topic there. This is Manas was emphasizing high stakes applications in the LLM era. So that's something that is certainly very important, and we should try to summarize in our synthesis. And Louis Lamb presented his. He also talked about neurosymbolic, and I guess Gary, that was your emphasis that we need to combine these two. And Lewis gave a good presentation on that topic as well. Then that was the end of the first track. Then we moved on to foundations. And I gave a brief introduction to the foundations of mathematics, especially topos theory, and kind of compared the situation in mathematics to the situation we have here in ontologies. Devika Madali gave a presentation on facet analysis, faceted classification, which is an interesting example of a link between ontologies and this kind of more library science classification, and also in a better understanding of the foundations of ontologies. And then Mark, are you here, Mark? I don't know if you could make it today. He pointed out a number of problems that we face when trying to convince researchers and others to make use of ontologies. And they had a number of concerns, a number of questions about why one would use ontologies. And Mark suggested a number of ways that we could quell these concerns. And this certainly was a real call for action on our part to make ontologies, to present the ontology field in such a way that people would find them easier to make use of and take advantage of them, particularly now in the AI era, or an AI era. Then Nicola, the last speaker, gave a foundational talk on ontological analysis as a search for truth makers. And this is one of his slides. It kind of summarizes what he was presenting. And so with that reminder of what took place in the first two tracks, I'll now open it up to discussion. And try to give me some ideas, try to give the summit ideas about how we can synthesize all these disparate ideas by the speakers in the first two tracks. John, are you capable of unmuting? Alex?
Sorry, right now I don't have idea to say something.
Oh. Janet?
Yeah, hi. So I was wondering, a point that you made, I think, in your talk, about use of ontologies without reasoners. Did you say that ontologies may or may not be used with reasoners? And I was wondering if we have a position on that.
My point wasn't that you didn't have reasoners, but there are many kinds of reasoning.
Okay.
That if you have a different notion of logic, such as in Topos theory, they have many notions of truth, then you get different ways that you can, use logic, that you can
Right.
make
Okay.
inferences.
Okay. So not
That was
that.
more my point than that.
Yes.
You
Okay.
shouldn't
So
use
I
logic.
misunderstood then. I thought so. So the Mark Musen's talk brought out the idea that and John said that ontologies are metadata, and when you're talking about metadata, you're talking about ontologies. I think maybe we could say ontologies are metadata that support reasoning. And that's so if we tie the reasoning together with the metadata idea, then those are both more concrete, accessible concepts. And then if we went back to Gary's diagram about the AI and the learning, reasoning ontologies, that the ontologies need to be present in metadata, and they need to be present in metadata that support reasoning. That's a concrete sense that I'm trying to derive from a lot of good stuff in these presentations. And I think Alex has been trying to get everybody on the discussion board talking about what is an IT ontology. And I wonder, Alex, if you, how do you like that idea that ontologies are metadata that support reasoning?
Alex?
So this is maybe important discussion to write to our page on our site, because we have there now maybe 10 definitions of ontology. I mean about IT ontology.
Right.
Okay. And then if you have one more, it would be great to put it there.
Okay.
I mean, it's not a very topic to discuss right now. Let's say my opinion. It's important to collect these different valuable definitions.
Right. So I don't know. Okay, I'll try to do that. But so Mark Musen's talk about the resistance to thinking in terms of ontologies, I thought was very, very important that we grapple with. That people still think about ontologies as something other than metadata and other than reasoning. And so I was hoping that, we could draw from his talk and from the things that other people have talked about this year to drive home the point that the only way you would say you're not interested in ontologies, and I'm not trying to put, Alex, I'm not trying to put you on the spot, but I think the only way you would say you're not interested in ontologies is if you're not interested in standardizing and metadata. And of course, everybody should be interested in standardizing and metadata. I don't know if I'm making my point here, but I thought that was, I thought that what came out of Mark Musen's talk and John's response to it was very clarifying for helping to synthesize the ideas that we have here.
That sounds good. I mean, one key notion about ontologies and classification systems, I guess, as well, is the purpose of this. You have to, what your purpose is dictates to a large extent what your ontology is going to be. So, Alex, you mentioned all 20 different definitions of ontology. maybe what's really going on is that there are at least 20 different ways that ontologies can be used to 20 different purposes. And I would think even 20 is not, there's more than 20 different purposes for ontologies. What do you think? Is that, when you look at all the definitions, would you see that there's a common core and then each of them is basically talking about a different purpose?
Yeah, it was idea for special, let's say, research to collect all valuable definitions from valuable sources and then to think hard about differences, about common knowledge and in these definitions, and to think what is the way to discuss these different definitions. It's a subtle question. May I say that at first approximation, ontology is a dictionary of one or another area of knowledge. And this is the first important idea of ontology, to keep these definitions, to keep this terminology systematized, keep together with connection between different terms. This is ontology.
Right.
With formalization we have.
Right, and the formalization is what supports the reasoning. So it's a dictionary with formalization that supports reasoning.
Absolutely.
And one would, what's that?
Absolutely.
Yeah. So the one would think that definition would be demystifying in order to address the problems that Mark Musin was talking about. That why do we need? If one said dictionary with definitions that are formalized to support reasoning, and it's encoded in metadata for some purpose in some application, those definitions of ontology and IT ontology get closer to what's accessible and I would think of interest to the broader public. I'm interested in going back to Mark's list of the objections that that people give him about ontologies are old-fashioned, ontologies are obsolete now that we have data. And if you say, well, don't you need a dictionary with definitions that are formalized so that you can reason with them? Or, I would think that the funders that he was trying to interest might react to that language better than to the ontology language per se, which always gets confounded with philosophical ontology.
So we have Eve?
Yes, thank you. Yes, Ken. Yes, just I could not follow all the sessions of this Ontology Summit, which is very interesting. I'm from France, and I am working on especially on standards, classification standards, and terminology standards for industry. Nicolas Guarino, who was the last speaker, I did not follow his presentation, but used to say that there is ontology with a big O and ontology with a small O, you see? And we were talking about, and it struck me always that we don't make, there is a gap between the ontology in a philosophical sense as metaphysics, primary philosophy or things like that, and ontology as an artifact, computer artifact, which, yes, try to capture some semantics in a syntax and for a given domain in a given intention. So it's something. But on the other hand, I think it's also important for, yes, all this question around technology, AI, LLM, and things like that, to have also a philosophical background about what is the being, ontology, that it is the discourse of a being in philosophy. And from my understanding, yes, we used to have an Aristotelian ontology with object and properties, like for instance with BFO, basic formal ontology, with independent continuant and dependent continuant, and after we have maybe the occurrent, but it's something added in BFO, I think. And philosophy is also a process, and it's always improving, changing around the different years. And today, in the contemporary philosophy, I think the ontology is more focused on the concept of process, I think. And I think also in engineering, it's my domain, and where we have always a process of design, a process of production, of construction, of operation, and using also physical process or chemical processes and so on. I think it is we need this kind of philosophical background to design an information system and use. Yes, ontologies for as artifacts for a given domain, a given intention, but we need maybe something also more extensible to deal with all the contradictions we can have in traditional logic. So I'm not sure I was clear, but
Oh, that's very. Thank you. That's a good contribution. Michael DeBellis had a comment that a dictionary is not quite enough, that you do need more than that, that ontology is a model. Is that what you said?
Yeah, exactly. And I think calling it a dictionary brings up the wrong idea. And so, like, for example, one question is, how much should you put in your ontology, right? And I think there are some people who think you should put everything you can possibly conceive of and every axiom you can possibly think of in your ontology. And in my opinion, that's completely wrong. I think you need to, for me, you need to think, for me, in my opinion, you need to think of an ontology as part of a bigger system. That's when things start getting real. And when you start doing that, that will give you constraints about what you do and don't want to put in your ontology, because it'll be based on the requirements for the larger system. And once you start thinking like that, you're not thinking in terms of a dictionary where you want to define every word. You're thinking in terms of solving a problem and what kind of a model do you need to solve that problem.
Right. Yeah.
Just to say one way, I mean, in my opinion, one of the reasons that a lot of people in industry don't pay that much attention to ontologies is because they look like they're just sort of things that exist, in their own little world. And I'm sure, and there are definitely still advantages of having ontologies that sit along in their own little world. But the real benefit for an industrial application is when you bring an ontology into a much larger system and have it play a specific role, in that system. Like, for example, for like giving semantics to data lakes and data catalogs and things like that.
Yeah, but Now the question comes, okay, and this is going to be our next track. How does that affect interoperability? If you focus just entirely on a specific application, what happens to interoperability? Are you now just making a lot of silos that can't communicate with each other? Do you have any comment on that?
I think that's a question. I mean, my initial reaction is no, that doesn't lead to silos. But it depends on how you're using the ontology. Okay, so one way to use an ontology is as like a meta model that is serving as to provide semantics for a lot of different systems. So in that case, I mean, so that's what it's for. And then in that case, it's actually helping you to integrate all these different systems. But it's also quite reasonable to say, I'm just solving one specific problem and I don't care about, integrating with other systems right now. That's not the problem I'm trying to solve. And ontologies are perfectly fine for that as well. So yeah, I don't think, but go ahead.
Great point. Yeah, that's you really expressed it well. Thanks. Mike Bennett, you wanted to speak?
Yeah, I just wanted to pick up this idea of an ontology being a kind of dictionary. I think we need to decouple the notion of dictionary from ontology completely, and I'll explain why. Because if you think of a dictionary as being a set of words with written human-parsed definitions, that's not what an ontology does. And in fact, the reason to decouple them is there are kinds of ontology which also have those human readable definitions. So it's an ontology that also embeds within it some of the functions of a dictionary. You couldn't say that if you were trying to say that ontology was a kind of dictionary to begin with. You have an ontology, there's an open debate anyway about, for certain kinds of ontology, whether you rely on the human readable definitions or you rely on the axiomatizations, the actual properties and restrictions in the ontology, and the human readable definitions hopefully follow that. In some ontologies, people do the axiomatizations and then the written definitions are taken from somewhere else and they don't even say the same thing, which is a mistake. But it's a mistake you have to be able to describe and discuss. And you can't discuss any of that if you're already thinking of an ontology as a kind of dictionary. So you've got to separate out, if the ontology is a set of intentional with an S axiomatizations defining the meanings of things that a machine can read and that's unambiguous and so on, and there's different kinds of ontology that will do that in different ways. And then a dictionary is something that has human readable words. Now you can describe, bad practices of ontology, like some people will take the dictionary definition of a word and then pop it in a class and then bung a bunch of axioms around it that may or may not mean the same thing. You've got to be able to describe all those distinctions between dictionary and ontology by not muddling them up to begin with.
Right. Janet, you have your hand up.
Right. So some of these objections to the dictionary idea are missing the second half of the definition, is that it's formalized to support reasoning. Does it support reasoning successfully for your purpose? To bring in Ken's point, you're doing it for a purpose and you want it to support reasoning for the machine. The dictionary word might imply emphasis on human readable, but it's really a dictionary for the system to use in its reasoning to achieve some purpose. Now, I'm also curious for the Mike and Michael comments there, what your elevator pitch would be to people who say ontologies are too hard, they're obsolete, they're not needed anymore, we've tried that, it's a dead end. And saying, well, if you put the whole big system together, then you'll see that they play a useful part, is not adequate for an elevator pitch. So I'm trying to figure out, how do you get people's attention to say, why should I be thinking about ontologies at all? Now, Yves' point is, and Nicola's talk, is important is that this is for the agent's perspective, for the IT agent. It's their world. It's what's representable in their world. So it's the philosophical ontology is how we think about our world and what we might want to put into their world. But the idea that we're creating a world for an agent, and Gruber used this in his 93 definition, that what exists for an agent is what is representable in their ontology. So it is very helpful to have those two ontologies sharply separated, related, but sharply separated. Final point about interoperability, you can't mandate that in advance. So all you can do is be concerned with it, because you're trying to achieve your purpose. And if you're waiting until interoperability can be set to achieve your purpose, that's going to be a long time coming. But if you think about how am I defining my terms in my application area for my agent to achieve some purpose, and then you're saying I also want to be aware of the fact that I might want to reuse this, or someone else might want to reuse this, or I might want to have automatic interoperation. That's the best you can do on that side, I think.
Well, if I can maybe respond on that. So I think we're looking at when you use reasoning as the defining feature of an ontology, I think again you're looking at a subset of the kinds of things that could be called an ontology. I think going back to the original Gruber definition, I think formalization of a conceptualization. A lot of people don't like that because it seems too vague. I like it precisely for the reason that it's not vague, it's abstract, which is not the same thing at all. Every other kind of ontology either narrows down the kind of formalization or narrows down the kind of conceptualization. And the point is that you can have a model that finds the real meanings of things, and it's not a philosophical. So a philosophical ontology, that's part of that. That's, the study of what is. That's the philosophical definition of ontology. Well, some people call philosophical ontologies is slightly misleading on that basis, because it's really, you have ontologies like BFO and Dolce and so on that are modeling meanings of things in the world, and you've got ontologies for reasoning, for semantic web and so on. And yes, being able to reason over ontology is also a good quality measure that ontology is not meaningful. It doesn't make it meaningful. A lot of people in the semantic web have this magical thinking that as soon as it's in an RDF triple store and you run a reasoner, suddenly meaning just appears from nowhere. There's people who've not read any cognitive science or anything, obviously. So if you think of an ontology as being something that represents either things in the world or data about things in the world, it's some formalization of conceptualizations. A subset of those uses a limited set of constructs such that it can be reasoned over or can be proven to be reasonable over in limited time, for example. Others are not, but are still ontologies. So I think if we've got to not make the mistake that a lot of ontology developers mistake of working within one narrow context and then defining everything just in that context. You'll start with what are ontologies overall. Now, I want to do reasoning. What's an ontology for reasoning? I want to do data integration. For that, I don't necessarily need just the subset you can reason over. What I do need is all the meanings of things, the intentional with an S definitions of things, such that each definition is consistent with each other definition, so I can map my data to that and tell my different data sources, I can tell that they're integratable. If I'm doing reporting or human description of stuff, I want to be able to have formal logical definitions of what is a legal person, what is a contract, etc., real things. So that's where we got to keep the definition of ontology general and not lock it into reasoning or dictionary or any of these things that any good legitimate subset of ontologies can do, but is not what they all do. Otherwise we're only talking about a small branch of the tree and not the whole thing.
Thanks, Mike. Janet, do you want to comment? Janet, you had your hand up briefly.
Okay. So I would broaden the definition of reasoning and say that everything you're doing with your schemas and coordination is reasoning. It's not elaborate reasoning, but it's quantified. It's formalized. It's so it's a theory and a model that that an agent can operate with, and so the conceptualization definition that Gruber was using came from the Genezareth and Nilsson book on logical foundations of artificial intelligence. And so they were talking about a conceptualization for the use of an agent. And we had some talks, I can't remember who was emphasizing this, but the importance of bringing the agent back into the picture. And the agent is what does the reasoning. And Ram was also talking about this, agentic AI, and Gary was. The ontologies don't exist as dictionaries, free-floating dictionaries. They're used by agents. And I think that's something that the semantic web unfortunately got away from, was that original idea that that an ontology is a conceptualization. It's a formalized conceptualization that is used by an agent to provide services, as part of some declarative architecture.
Well, aren't you defining a subset of ontologies again? You're describing ontologies that blah blah blah.
Well, give me an example of an IT ontology. If we stick with, Alex's point that we're talking about IT ontologies here, not just ontologies, philosophical or human to human ontologies. What are other examples of IT ontologies?
Well, I wasn't, because I was talking about ontologies to human meaning as well as machine meaning, and two classic examples in IT that are very prevalent in banking and elsewhere and finance, and that is integrating data. If you've got different data sources and each element of data in each of these sources means a different thing, sometimes they mean the same thing, sometimes they mean subtly different things. Often when they mean the same thing, they have different labels, and when they mean different things, they have the same label. So you need an ontology that describes the meanings of things, so you can do a hub and spoke mapping. Because what happens at the moment is, otherwise, you've got like 5 data sources, and then you buy a 6th data feed, and now somebody has to map that 6th one to each of those 5, and then you buy a 7th one, you map it to each of those. And not only is that horribly expensive and inefficient, but also there's no way of validating those mappings. Whereas if you have a hub and spoke, the hub is your ontology, a conceptual data ontology in this case. It has data types, so dates are a data type and text a string and so on. You've made some typing decisions, so it's a designed artifact, not a concept ontology, but it's one aligned with the conceptualizations so that you can integrate all those data feeds. Now, hopefully, most of what's in those data feeds can be described in a nice subset like description logic, so you can prove with a reason that it's consistent. But some of it won't be, so you're going to have to deal with deontic and modal at some point and all the others. Another one is reporting. I want to know, say I've got a central bank that's taking reports from different banks. I want to know that what each bank sends me with the same box that they filled in under the same label actually means the same thing from bank A as it does from bank B. Well, how do I know that unless I have formal declarations of what those things mean, in order that the reports a human sees, or a management dashboard for risk and compliance management or general management functions, human facing meaning? I need all of those. I need them plugged into the IT system. I need them plugged into the humans as well. None of that's got anything to do with agents, which is another very important use case. That's why I say these are all branches of the tree of things you could do with an ontology, and things you want the right kind of ontology for, all of which are subsets of something that's a formalization of a conceptualization. Right.
But the agent word, as used by Genezareth and Nilsson and as used by Gruber, it is an engine, an inference engine, a reasoner, a search engine, a query engine. It's any kind of engine that uses the persistent data store So the original idea was the data revolution, that you have a persistent data store, and that can be data, or it can have rules and concepts and whatever, but it's a persistent store. It's, you're separating the program. You're separating the program into the persistent data and the engine that operates on the data. And you want to, so I think it's helpful to go back to the declarative turn in programming and to see how these ideas arose in that context, because everything you're talking about, I think, is meaningful in the perspective that I'm trying to develop here. That the data, the metadata, what kind of query engines or agents, quote unquote, can use how many different data stores, how many different agents, networks of engines and data stores and things like that. Networking them is just built on this declarative architecture, where you're asking for services from an engine that is using a persistent record store. And I think, Mike, I agree with you about the fact that people keep confounding the human world and the IT world, and I think you're getting at the question of, are we doing this well? When we're talking about the human needs, we're talking about whether we're building the IT ontologies properly and usefully and having value and that kind of thing. But that's a separate question from just the technical questions of what is going on in the architecture. And I think we need to separate those so that each can be addressed in its own right, because they have different characteristics and requirements and things like that.
Well, there's a more profound difference than that. And then I'll let others jump in because I'm a bit lost here. But there's ontologies which think of the meaning of what does it mean to be a security? If you ask a lawyer, they'll tell you that the definition of security is based on a particular legal case from the 1940s. That sets out the meaning of security. That's got nothing to do with IT. The job of IT, like any kind of engineering, if it's done properly, is a separation of concerns. You start with a business view, say, for example, a set of business requirements for a bridge or a toaster or something. You then derive a design that meets that business view of what the world is or what the world could be if you're designing something. In the case of ontology, it's simpler because you're just modeling what the world is. So you start by understanding what is a legal person, what is a contract, what is a security based on law and other per se social constructs. Most of the things that are not physical, if it's not a house or a tree or something you can poke with a stick, it's generally not always, but often a social construct. Those are real things, commitments, obligations, laws, jurisdictions, all of that. You model that, and you can do that with an ontology, and I've done it, and I have no hesitation calling it an ontology. And then the semantic web people think it isn't an ontology because it isn't in triples yet, and you haven't reasoned over it, and so on. But it's defining what things are, and you can do that in OWL and serialize it as OWL, or never run it in a reasoner because you've got lots and lots of levels of abstraction, the opposite of what you want in a good design. Because if you're defining the business-facing world, it's the opposite of good design. A good conceptual model should not look anything like a good design and vice versa. So you separate your concerns, you model what is a contract, what is a legal person, what is a jurisdiction, etc., using formal declarative logic. It could be first order logic, common logic, description logic, I don't care, whatever it is that you need to describe what those things are. Now you can go to IT and say, they go, oh, right, well, I can replace your place of birth with a string, and I can replace your date of birth from a day to being an actual data type, and I can do all this data-y stuff. Great. And now I can start doing integration, or I can talk to this software agent or that human agent, or whatever kinds of, or that querying engine, whatever it is you're talking to, as a design thing. But to have an ontology that is of real things is just as important as a part of the engineering process. And it's still an ontology, and it's not there for data. It's there to describe what the things really mean to begin with, because that's different. Meaning doesn't come from data.
Well, this is where I think what Michael.
Well, let
DeBellis
me interrupt.
Can I just bring in Michael DeBellis's point about we need the broader picture of the whole spectrum of ontology development from the human through the IT and back again. That broader picture is sort of what this whole summit forum effort should be responsible for.
Yeah, but no, what I wanted to do was to pose a kind of question for us. Let me share the screen. So let's look at this slide that shows this continuum. Isn't everything along this continuum just different kinds of logic, different kinds of reasoning? They're all, down at the bottom, it talks about thinking slow, thinking fast. So this suggests that in some sense, these LLMs are thinking, just a different kind of thinking, kind of a different kind of search.
You can
Is it
say
reasonable
that,
to talk about all of this continuum as being different kinds of thinking, different kinds of reasoning, I should say? Right, so just posing a question. Now let's see what can people say about that? I just want to pose this and see what we can say.
So I agree with that. So why don't, Michael, you were going to say something.
Yeah, I was going to say that, I mean, sure, to some extent, they're both doing reasoning, but the kind of reasoning is so fundamentally different that I would not say, I wouldn't put them on the same spectrum, and just say, oh, well, they're all doing reasoning. No, because what an LLM does is completely a black box. It's completely based on statistics and I mean, it's actually very much like the distinction in philosophy between analytical reasoning and inductive reasoning. So an LLM is all about induction. It's all about using lots and lots and lots of data and mathematical models to solve problems, whereas an ontology is completely the other side. It's about doing formal, logical, very, very rigorous kinds of models, and that is appropriate for other kinds of problems. So yeah, to me, it's a mistake to think of them on the same continuum. And in fact, I actually find it works better with my clients when I do just the opposite. I point out how different they are, and I say, and I think, by the way, I think retrieval augmented generation architectures are an amazing example of this, that the strengths of one make up for the weaknesses of the other. So ontologies in general, require you to know like a query language, and which most end users don't. And so if you can use what you can with a RAG, you can use an LLM to interact with your ontology with natural language. That's great. But then the problem with the LLM is that it's a black box. It can make up explanations, but really those explanations often have nothing to do with the actual training that caused the answer. Right. So when you combine them, you can get the best of both worlds. You can get the explanatory power of like using ontologies, the explicit knowledge representation, and you can get the ease of use of being able to interact with natural language that comes from like LLMs.
Yes, the term here is neurosymbolic, and the point is that there is the neural work is a continuum, and it of everything with probabilistic relationships among them. It's what you look at when you look at a dictionary, and every word has a multiplicity of meanings, and even that selection of meanings is just an approximation because there's a continuum in there. But when you get to the symbolic, when you get to something like a bank, you must have absolute precision. You cannot have a fraction of it's down to a fraction of a penny at the last step of the approximation, but all the computations in between must be absolutely correct. And this is a kind of problem that the LLMs by themselves cannot do. And so what you need to do is to use LLMs as the interface between your natural language system, between what people say and what your computer uses. And the interesting thing about the recent work with the various systems of is that you must have that option of going to absolute precision for banking, but you also want to have the option of letting people talk in their ordinary ways. And so what you do is you let people say whatever they want to say. The system translates it into its internal precise representation and comes back and says, is this what you mean? And if the people say, no, I meant something else, then you go through the cycle of trying to disambiguate where you get an absolute precise statement.
I'm seeing two different points of view here. Is it a continuum between these different styles of reasoning, or are actually they fundamentally different? John, is it a continuum, or are they fundamentally different?
The probabilistic form is a continuum, but for banking, for any kind of precise computer operations, you have absolute precision. It's 100%. You don't have any probabilities, unless, of course, your computer is using probabilities. But the thing is, the banking systems and a huge number of businesses, you must have an absolute precise answer, and you don't have any vagueness in between. What you do have is you let the system, the human being has a vague idea of what it's about, asks a question with a vague way, the system translates it to its precise form, and then comes back and says, is this what you mean? And this is what, by the way, all these systems have, that every one of these systems that's absolutely precise for banking and whatever else it is, has a precise form, and the input to and from natural language must always be disambiguated down to that precision.
Right. It might be better to ask whether it's a spectrum, because continuous versus discrete is another question that we're talking about here. So there's a spectrum of reasoning, and rather than a continuum.
Yeah, I think I would agree there. If you're going to say, certain systems must be, exactly precise, then you're talking about discrete, not continuous. Right. It's not like you can be slightly precise or 90% precise. You have to be totally precise. That is a sharp distinction. It's not a continuum anymore. I think it might be worth mentioning that it isn't just a continuum.
No, it's not a continuum. It's neurosymbolic. Neuro is one thing, the vague continuum. Symbolic is precise. When you get to the huge number of applications, anything on a digital computer is absolutely precise. And even when a computer is doing something vague, it's still doing it with a precise program. So and it's approximating what people do. Now, the human range, people can do the vagueness, but they can also do the precision. And so the term here is neurosymbolic, and it's not a continuum. It's either neuro or it's symbolic. And these systems that are precise must be precise, not vague.
Right. So it's not a continuum.
Can I make
we've established that. Julian?
Yeah, well, I mean, I've sort of sat in on this for some time, and I listen to all these people's troubles, and I know nothing really about ontologies. completely self-taught. It was just that I had a problem, and that is to see whether the biology with which I'm pretty familiar can actually be turned into engineering solutions. I was given a job from being a zoologist into an engineering department in another university, and they said, well, there you are, tell us the tricks animals use. Well, that is a very, very difficult problem, actually. And listening to the sort of problems that, can I say, you professionals have to meet and tussle with, it gives me a lot of encouragement, because biology is a very, very vague subject. I mean, if you think of a single cell, which has got something like 20,000 different proteins in it, each of which is doing a slightly different job, and the cell has to decide which one it's going to use for which job, you can't describe that at all. But you're trying to work out some general rules by which it might work. But what you're then trying to do is to work out how those general rules can be sufficiently vague to encapsulate the biology, but then transformed into something sufficiently specific for an engineer to find useful. Because if anybody's specific, it's a bloody engineer. Admittedly, they have to make things work, and if they fail, then they can't afford the insurance. So there's some very practical problems here. But this divide between the vague and the precise, I tried a number of ways of looking at it, and eventually ended up with an ontology. And I've been battling with that for about the last 15 years, I suppose. And I'm slowly wrestling it to the ground. It's very encouraging to hear people who've been doing this sort of thing all their life and actually know some of the theory behind it, to hear that they have the same problems. So this is a sort of, for me, it's a philosophical and intellectual hospital. It does very well. Thank you very much.
So let me tell you a little story. One day, one of the other faculty in the department that I knew, he was doing, machine learning statistical things for biologists. Well, these were, I think they were looking at bird behavior or something like that. So he was doing great things, with, the machine learning and coming up with answers, and, the biologists apparently were quite happy with it. And so I asked him, what do you tell them exactly? I mean, when you come up with an answer, do you know exactly what it means? Do you know the meaning of it? And he said, oh, no, that's the biologists. They're the ones who determine the result of what I did. And I said, oh, okay, that sounds good. A few days later, he ran after and grabbed me and he said, Ken, tell me about ontologies. It was apparent that the biologist assumed he was the one who knew what his all meant. And the biologist, so the biologist thought he was the one. He thought the biologist was. Neither one actually knew what these results were. So this kind of tells you there is really a use for ontologies, and that these people really need them. They may not realize it, and they may be producing papers, that are, have lots of statistical significance, but they actually don't know what the result means.
Right. Well, if you have to translate it into engineering terms, which I'm doing gradually, you have to find out what it means in terms of process and result and stuff like that. The biological system doesn't know. And well, a friend of mine in engineering once pointed out, when I was having difficulties with an experiment, he said, the only way you can do an experiment with a biological system is to tell it that you're going to do an experiment on it, and then do a different one on it while it's not watching.
That's good.
Then you might get a reasonable result. But for the rest of it, we are all so adaptable that but we don't really notice it. And yet that, in terms of categorizing things, is the most difficult aspect of biology.
Yes.
One thing I'd like to mention is DeepSeek. That's this recent this system that has been coming up as a competitor to the LLMs. It's this Chinese system. And the interesting thing is it was developed by a bank. It was a banking system that developed DeepSeek as a way of communicating in ordinary language to and from people in the bank. Now, the bank, everything is absolutely precise down to the last penny or yen or whatever. And the point is that there is the precision, and that precision is you cannot use anything vague in the bank. It is precise. And then so their system is DeepSeek is basically a precise system, symbolic system. Now, the thing is that it can be used for vague applications, but the vague applications, it always breaks down into one or more selections of whatever kind of precise system you need. And the ideal would be to have a combination where you can have the vague approach in the discussion with with people. Each person might have a precise meaning back in the head. However, the statement that comes out is always a precise in one way or another, and then it has to be interpreted into something that where the computer maps it into its own precise version and comes back with a statement in English or Chinese or whatever that is a precise statement to and from that internal form. And it says, is this what you mean? And that's where you have that dialogue where the person and the computer break it down onto the point where the person finally gets to map it into a statement that is translated exactly to and from its internal form. So DeepSeek is basically a precise system, and the thing that we're doing with our AvivoMind and Permion system is to have the vagueness and the precision and have both. But the precise, when you talk about the neurosymbolic, you're either precise symbolic or vague neuro.
Okay, great. Actually, we've run out of time. I think we've made some great progress with synthesis. And with that, I will adjourn, and I'll ask everyone, please come next week where we'll begin the next track on interoperability. Thanks, everyone. Thank you for your contributions.
Thank you.
And see you next week.
Yeah.